So this is an interesting question. We've got this circuit set up where we have a battery connected to the rest of the circuit with a switch in between. We've got some resistors set up and some capacitors set up. And the question asks us to find the current through R2, this resistor right here, when the switch is immediately thrown and when the switch has been open for a long time. So in other words, for time approaches 0 and for time approaches infinity. Well, this is more of a conceptual thing. When time approaches infinity, capacitors are completely uncharged. There is no charge on any of these capacitors, so they offer zero resistance to any flow of current because there's no charge on that plate to resist the current. So at time 0, switch closed, this circuit resembles a different circuit that would look something like this. R1, R2, a straight wire because this is offering zero resistance, there's no charge accumulated on it, and this, R1, R2, R3. Well, you can probably guess what the current through I2 is. It must be 0. Why? Well, because if the current is flowing into this junction and it has the choice of facing zero resistance or non-zero resistance, it's all going to flow through this branch of the circuit. But we can prove that. We can use that, do this using Kirchhoff's loop rule. So let's say we have I1 in this direction, I2 there, I3 there, and I4 there. So if I look at this loop going from, let's say, A, B, C, D, starting at A, going all the way around. So I go around, I encounter nothing, I encounter nothing, I encounter nothing. Now I'm flowing in the backwards direction of I2, so I add the voltage of I2, R2, and then that's nothing. I'm at the end. So I2 equals 0. And sure enough, I4 equals 0 as well. So what happens then when the switch has been open for a long time, so t approaches infinity? Well, then it's a different situation, because at that point, when all the charge that you can get on these plates is on the plates, you can't get any more charge on them, so it acts like a break in the circuit. So the circuit then would look like and now we have another break here, R3, R2, R1. So you can basically ignore this whole part of the circuit because it's broken. There's no connection between this side and that side, or that side and that side. So we've sealed off R4 now. And so now, in order to find the current through R2, we just have to combine the resistors into R12, where R12 is just R1 plus R2. So it's just, well, we're not given values, so it's just 2R. And then the current is equal to EMF over R, whatever the resistance of R12 is. So the current is equal to EMF over 2R. And that is the same, of course, through each one of these resistors because they're both in series now.